Day 2. Yesterday we built the wrench manually. Today we throw with the mouse. Welcome to Wrench Design class, the core of our automation pipeline. The Python script that we talk about today will essentially generate a complete parametric wrench in a few seconds. Essentially, you'll need no GUI, no mouse, just code. So, what exactly are we building? We're building a class that accepts design parameters. It's going to take the parameters we discussed about yesterday. It will just output a watertight STL file, which will be ready for our CFD. Let's talk about what these parameters are, what the code looks like in the next scene.
To understand how the macro exactly works, let's take a look at a higher level understanding of what the macro does. Once we start the macro, we make these rudimentary elements and make them with the correct position adjustments. Then we make these Boolean cuts and fusion to make the entire wrench geometry. We showcase the design and export it to STL. Let's dive a little deeper into what the code is all about. So the code essentially automates the creation of this 3D wrench geometry. It uses the part module in FreeCAD to perform constructive solid geometry. The wrench is essentially defined by data and not hard-coded coordinates, where changing one number updates the entire 3D module. Now the lines here that talk about part.makeBox and part.makeCylinder are the commands we use to create these raw 3D primitives. The part.feature allows shapes to be visible and editable in FreeCAD GUI. The recompute function essentially tells FreeCAD to refresh the 3D view and calculate the geometry again. Once we want to make any changes to our parameters and want to visualize what that would look like on the screen, the compute essentially does that for us. Coming to the code functions itself, there are these functions that we're talking about. There's init, create handle, create head, cut opening, and build. Individually, each of these help in building our rudimentary shapes and interfacing the code with our particular FreeCAD GUI. So the build function is primarily the most important one, where this is the manager that executes all the steps in an order, because if the order gets missed, then you end up with errors. Talking about the primitive creation itself, we create the basic shapes as we saw previously. There's also the transformation. We use vectors and translate to move the parts into correct relative positions. The Boolean fusion also generates a cylinder at the end of the handle, and Boolean cut creates a temporary block to bite, essentially, a hole out of the head, creating the jaw. Talking about the execution block itself, this demonstrates the power of the script itself. It is fully data driven. Same logic can generate two different tools by swapping the input data. We have parameters that we can see on the screen right here. Something like the handle length, opening width, thickness, handle width, and head size. Individually, each of these help us parameterize the design of our wrench. So there you go. That's how the macro works. Now let's execute it in FreeCAD and understand how exactly we can use it with the FreeCAD GUI. Welcome back to day 2. So again, we'll go the same route. Let's just select the part. Now, since day 2 is all about macros, how do we interface Python with FreeCAD? Let's go to macro, let's go to macros. Now, I already have the day 2 macro ready for me, but you would probably need to create it with this extension .fc macro. But since I already have it, I'll just click on edit here, and this is the Python code. Now, this Python code is essentially a WrenchDesign parametric class which generates the wrench geometry based on a dictionary of these parameters. We'll create the handle, we'll create the head, we'll cut the opening with Boolean, and essentially we'll build everything into the final STL object. We can control these parameters from the main execution block. We'll just talk about that in just a bit. Let's go to Windows, Tile, and we have the unnamed body right here. So let me just hit play. So here we have it. This right here is our wrench design. Now we can see that there are a few Boolean operations that have happened. Essentially we have this box and another box that was cut from this cylinder, and ultimately we end up with this particular wrench. Now I can control a few things. So as you can see, the handle length just increased. The handle width can also be controlled here. The head size can also be controlled. And we can also control the operating width. This goes to show how powerful the macros essentially are, because tomorrow in the future code where we want to parameterize our CFD designs, we will be using exactly these inputs for our macro so that we can use Python without the GUI or opening this particular screen. So there we have it. This was an attempt to explain how the macro works. In tomorrow's session, let's understand how exactly do we create the wrench handle. Until then, see you next time.